from our last video, we learned how to resolve forces. In this video, you're gonna learn how to apply F equals ma. So let's look at the first question. Pause the video for 4 minutes and try this question by yourself. Okay, now let's read the question carefully. The question says, a particle P of mass 2 kg is moving on a smooth slope and is being acted on by a force 4 Newton that acts parallel to the slope as shown. So everything is labeled in this diagram, but I highly recommend when it comes to a mechanics question in the exam, you must draw a diagram. We call that diagram as a force diagram. So let's draw a force diagram by ourselves. So first of all, we'll copy down the diagram that they have already drawn. So I will draw an inclined plane, an inclination to the horizontal, inclined with an angle alpha, and the particle is considered as a object that has no dimension, but it has a weight for our convenience when it comes to calculation. So mass of the object or mass of the particle is 2 kg. So let's mark the weight to be 2g. 2 multiplied by acceleration due to gravity, which is g, gives you weight of the object. So let's label it as particle P. Now let's highlight the key information in this part. It says a particle P of mass 2 kg is moving on a smooth slope and is being acted by a force 4 Newton that is parallel to the slope as shown. So the force which is acting on this particle is parallel to the slope. So we'll mark it with an arrow with 4 Newton. And most importantly, this surface is smooth. Whenever they mention a surface is smooth, that means it has no friction. So we will discuss in another video how to solve questions related to friction. But in this video, we'll be mainly focusing on how to apply F equals ma with slopes without any friction. For smooth surfaces, we are going to apply F equals ma. So we managed to mark everything which is on the diagram. In addition to that, we mark the weight as well. Now let's read the second part of this. It says, the slope is inclined at an angle, which is already done, where tan alpha is 3/4. Now, in the exam, whenever you see tan alpha, when they refer an angle like this, you must draw a right angle triangle on a side. The purpose of drawing a right angle triangle is to figure out what would be the sine alpha, what would be the value of cos alpha, and by using tan alpha. So tan alpha is 3/4. I can write tan alpha, the opposite divided by adjacent is going to be, opposite is going to be 3, adjacent is going to be 4. So by applying Pythagoras theorem, this is confirmed, this can be confirmed that it is going to be 5. So hypotenuse is 5. So because of this right angle triangle, I know the value of sine alpha is 3/5. Value of cos alpha is going to be 4/5. These are some extra information, additional information you need to extract from this. Tan alpha being equal to 3/4. Even if they give you as a sine alpha equals 3/4, or what you need to do is draw a right angle triangle and write 3 opposite and 4 would be the hypotenuse. Okay, now let's read the next part of the question. Next part, they say work out the acceleration of the particle. Now, since the surface is smooth, we all know that this particle is experiencing no friction. Now we need to know which direction this particle is going to accelerate. Because of this 4 Newton force, this particle is going to accelerate upward direction. So let that acceleration be A. Keep in mind, whenever you mark the acceleration should be marked with double arrowhead like I did. Now, still we didn't complete our force diagram fully. So there are some other forces that we need to mark. They are gonna be the normal reaction to the particle, normal reaction to the flow. So if you look carefully, this particle is resting on an inclined plane. Because there is a contact, there will be a normal reaction from the plane on the particle. So I would draw a dotted line, because that dotted line is a must when you draw a force diagram, because if you look carefully, this angle is gonna be alpha. How is it is gonna be alpha? Because this is a right angle triangle. So this is gonna be 90 minus alpha, and this is 90 degrees. Therefore, if this is 90 minus alpha, then this angle should be alpha for all of them to be 90. So in the exam, you don't need to prove how it becomes alpha. You just write down alpha. Now, we managed to mark all the forces acting on this particle, including the normal reaction. Since this is frictionless surface, there's no friction. So now we have to apply F equals ma. Keep in mind, in any question related to force and friction or without friction, you have to apply F equals ma to two perpendicular directions. Generally, you would apply F equals ma upward, or you would apply F equals ma horizontally. But in this scenario, if you try to apply upward or vertically or horizontally, you would find it really difficult to solve this question, because every force on the marked in this diagram, you might need to resolve them to components. So in order to avoid complexity, we need to be smart. What we should do is, instead of applying horizontally and vertically, instead of resolving horizontally and vertically, what we could do is, we can resolve into two different directions, but still they are going to be perpendicular to each other. You could apply F equals ma along the plane, and it could be upward. Since the particle is moving upward, I'm gonna mark the upward direction, so along the plane. So this is how you mark the direction that you are gonna apply F equals ma along the plane upward. And the other way that you can apply F equals ma would be apply F equals ma perpendicular to the plane. For it to be perpendicular, I would draw the inclined plane, and I will draw the arrowhead in this way. So now it is clear, this is the way that you would show that you are applying perpendicular to the plane. This is the way that you would show along the plane. If you apply F equals ma downwards, just change the arrowhead. Now, sometimes we might need to use both these equations, but sometimes you might need only one equation. So let's see. Since we are trying to figure out the value for A, which is the acceleration, so we can try to apply F equals ma. Let's apply F equals ma along the plane in upward direction. Now when you apply F equals ma, first thing that you need to do is carefully look at all the forces acting on this particle first. So you have a weight component and you have 4 newtons and you have the normal reaction. Now, out of these 3 forces, one of the force is not going to be considered. We are not going to consider one of these forces. That is gonna be the normal reaction. The reason behind is normal reaction is perpendicular to the direction that we consider. So if there is any force which is perpendicular to the direction that we consider, we would not include in our F equals ma equation. So that means we need to worry only about 2 forces. That's gonna be 4 newtons and the other one is gonna be 2g, which is gonna be the weight. Okay, so let's resolve all the forces acting along the plane upward. So what are the forces acting? It will be 4 newtons. So you will be having the full effect of 4 newton. And minus. Why it is going to be minus? Because this 2g has a negative effect. It will slow down this particle moving upward. So this 2g is acting opposite to the direction that it moves. So or we considered. So we would write 2j. The component of this weight is going to be 2g. If we are going across, if you are going through the angle, it will be 2g cos alpha. If you are going away from the angle, which is mentioned here, it will be 2g sin alpha. So here we need 2g sin alpha. So that will be 2g sin alpha, but it is gonna be minus because it is acting in the opposite direction that we are applying F equals ma. Now we managed to figure out all the forces acting in that direction, and mass is gonna be 2, and acceleration of the particle is unknown. Just find A. So now see the importance of drawing a right angle triangle. So whenever we want a value, we can always recall. See, sin alpha is 3 over 5. So you can plug sin alpha here. So 4 minus 2g, value of sin alpha is 3 over 5 and 2a. Now look at the unknown. It's only acceleration which is unknown. You can easily subtract acceleration. So this is going to be 4 minus 6g over 5, everything divided by 2, ms minus 2. Now if you want, we can simplify it further. So this is going to be divided individually. This is going to be 2 minus 3g over 5 ms minus 2. So meters per second per second. So your acceleration numerical answer will be, substitute 9.8 to g. So it's going to be 2 minus 3 times 9.8 divided by 5. Your answer is going to be minus 97.97 over 25. Decimal value is going to be minus 3.88 ms minus 6. Which means, even though we assume this particle is moving upward, we got a negative answer. That means actually this particle is accelerating downwards. Therefore, you can just write down the final answer. This particle is accelerating in downwards direction, which is gonna be 3.88 meters per second per second. That is our final answer. Now, let's move to the next question. This is exam style question. So again, this question is related to smooth slope, so no friction. So pause the video for 5 minutes and try this question by yourself. Okay. Now let's see how to analyze this question. As I mentioned earlier, when it comes to mechanics, it's a must that you draw the force diagram. Don't just try to mark forces on the diagram that they have provided. Draw the diagram by yourself. So we'll copy down the same diagram first before we read the question. So there's an inclined plane and inclination is 30 degrees, and there's a weight of there's a particle, and there is a horizontal force which is 30 newtons. Now let's read the question carefully. The question says a force of 30 newtons, we'll highlight the key information, 30 newtons acts horizontally, which we scanned, on a particle of mass 5 kg. So that's extra information which is not provided in the diagram. So we'll mark the weight of the object by using an arrow. So weight is, mass is 5, so weight is 5g. So as soon as you mark it, it's a must that you draw a line perpendicular to the plane and mark this angle to be 30, because in our previous question we just learned, if the inclination of the slope is alpha to the horizontal, it will be same for this angle. So if this is 30 degrees, it will be 30. The reason is, this is a right angle triangle, this is going to be 60 degrees, and this is 90, so obviously this should be 30 again. Okay, now let's read the next part. Next part says mass of 5 kg that rests on smooth slope, so no friction, that is inclined at 30 degrees to the horizontal as shown in the diagram. Find the acceleration of the particle. Now let's assume because of this force the particle is accelerating upward. If our assumption is correct, we would get a positive answer for the acceleration. If our assumption is wrong, we would get a negative answer. That means it's actually accelerating down the plane. Now, before we move forward, double check whether you have marked all the forces. I think we need to mark the normal reaction, which is gonna be R. Now, since we managed to mark all the forces, so there are two equations that you could use. One is applying F equals ma along the plane upward, or apply F equals ma perpendicular to the plane. Now let's start with the first equation. If the first equation is not enough, we'll have to apply F equals ma perpendicular to the plane as well. So first let's apply F equals ma along the plane upward direction. Now when you apply F equals ma along the plane upward direction, there might be another angle that you need to consider when it comes to resolving, that is 30 newtons, because these two lines are parallel because they are horizontal direction. This is gonna be alternate angles, so this is gonna be 30 degrees. Now when you resolve this 30 newtons along the plane, that is gonna be 30 cos 30, because when you're going through the angle, it will be cos. When you're going away from the angle, it will be sine. Now we have 30 cos 30 Then what are the other forces that we have? We have 5g. So but this 5g, which is weight of the object, has a negative effect to the direction that we consider. So it will be minus 5g. When you resolve this 5g along the plane, it will be acting in this direction, so it will be 5g sine 30. Because we are going through the angle, if we go through the angle, it will be cos. If we are going away from the angle, it will be sine. Will there be any effect from the normal reaction? No. Reason? Because the normal reaction is perpendicular to the direction that we consider. If any two forces are perpendicular to each other, there is no effect on each other. Okay, now we managed to resolve all the forces. Now we'll try to apply MA side. So mass of the object is gonna be just 5 kg. Acceleration along the plane upward, we assume it to be A. Now it looks like that we have to apply the value of cos 30, value of sine 30 here. So cos 30 is a known value, known trig answer. So it's gonna be cos 30 is gonna be root 3 by 2, and sine 30 is gonna be half. It's gonna be 5a. We're gonna cancel every bit with 5, so 5 is getting cancelled. 30, how many times 5 goes into 30? It will be 6. Then 2 and 6 gonna get cancelled. It will be 3. It will be 3 root 3 minus g over 2 will be the acceleration. So if you want a numerical answer, your acceleration is gonna be, type this one in the calculator, substituting 9.8 to g value. So this is gonna be minus 9.8 divided by 2. Your answer is gonna be 0.2961 meters per second. So your acceleration is going to be 0.29623 SF.